Today's video is going to be about the identity matrices and inverse matrices. So the identity matrix, denoted by I, is a square matrix that when multiplied by another matrix equals that same matrix. So if A is an n by n matrix and I is an n by n identity matrix, then A times I equals A, and I times A equals A. The identity matrix contains ones along the main diagonal and zeros for the remaining elements. So for a 2 by 2 matrix, the main diagonal is here, and the other values are zeros. For a 3 by 3 matrix, the main diagonals are here, or is here, and these are the other values. There, that looks a little neater. So the identity matrix is important because it tells us if matrices can be inverses of each other. So two n by n matrices are inverses of each other if and only if their product in both orders is the identity matrix. So if matrix A has an inverse denoted as B, then AB must equal I and BA must equal I. So we're going to determine whether some matrices are inverses. All right, so a 2 by 2 times a 2 by 2 is going to give us another 2 by 2. So to find the first value, multiply row 1 by column 1. So negative 1 times 5 is negative 5. 2 times 3 is 6. So we add those together. Then negative 1 times 2 is negative 2. 2 times 1 is 2. So we add those together. 3 times 5 is 15. Negative 5 times 3 is negative 15. Add those together. 3 times 2 is 6. Negative 5 times 1 is negative 5. Add those together. So when we simplify this, we get negative 5 plus 6 is 1. Negative 2 plus 2 is 0. 15 minus 15 is 0, and 6 minus 5 is 1. But we also have to do this in the opposite order. We also have to complete B times A. So it helps me to rewrite them in the correct order. So I just flipped the order. That way I can still do rows times columns instead of thinking of it in the reverse way. So our first one is going to be 5 times negative 1 is negative 5. 2 times 3 is 6. Then 5 times 2 is 10. 2 times negative 5 is negative 10. 3 times negative 1 is negative 3. 1 times 3 is positive 3. 3 times 2 is 6. And 1 times negative 5 is negative 5. So when we simplify these, we get 1, 0, 0, 1. So since both of these equal the identity matrix, yes, these are inverses. So we're going to take a look at number 2. We're going to multiply R times S. So negative 8 times negative 6 is positive 48. 3 times negative 5 is negative 15. Okay, already 48 minus 15 is not 1, and the identity matrix always starts with a 1. So we don't have to do any further work at all to know that, no, these are not inverses of each other. So now I'm asking, does a matrix or does an inverse exist? Not all matrices have an inverse. Matrix A does not have an inverse if the determinant of A is equal to 0. If the determinant of A is equal to 0, there is no matrix or no inverse, So if we do have a determinant that is not 0, then this is how we find our inverse. So I'm going to walk you through that. First, we have to find the determinant. So the determinant of A is equal to A times D, so 12, minus C times B, so that's positive 6. 12 minus 6 is just 6. That's not 0, so we can find an inverse. So the inverse, A inverse, that -1 means inverse, is equal to 1 over the determinant of A, so that's 6, 1 over 6, times, and then we flipped this all around. So the way I remember this is A and D switch positions. So 3, then 4. And then B and C stay where they are, but they switch signs. So this was a -1, it's going to be a positive 1. This was a -6, it's going to be a positive 6. And then we just do scalar multiplication. So 3 times 1/6 is 1/2. 1 times 1/6 is 1/6. 6 times 1/6 is 1, and 4 times 1/6 is 2/3. And this is our inverse. So let's do this with number 5 as well. With number 5, we're going to do the determinant of A is A times D, so -8 minus B times C, which is -8. -8 minus -8 is -8 plus 8, which is 0. So if it equals 0, there is no inverse. And that's your answer. All right, those are all the examples I'm going to do with you today. Please let me know if you have any questions at all. Thank you for listening and have a wonderful day.